Hello and welcome back to the Mythruna Weekly live stream. Um, Tonight we'll be going over some of the stuff I accomplished this week with the paths and so on. Before I get started, let me thank my patrons. Picked up some new ones this month, Leon and Christian. Thanks for joining us. Um, if you're developers, let me know and you can get access to the open source parts of this stuff called MOS, the Mythruna open source software. So yeah, tonight I'll be going over sort of what I got accomplished with the roads, and I put together some diagrams and explanations on how generation is done, why it's done that way, and so on. And so we'll walk through that and show how the cities finally got placed and the roads were generated and sea routes generated, and then from there we can work on, if there's time, filling in towns and villages and stuff, which is basically following the same process with just some different influencers. As usual, up at the top here is the super secret link if you want to try the engine. That page also has a link to the Discord if you want to join the Discord. Thanks, Ron. All right, let's go ahead and get started. Let me put this out of the way. I went ahead and loaded this up. So yes, here's the towns and stuff. I've been posting screenshots to the Discord of different places, and this is kind of a cool looking town. It's not a town yet, right? But it's a cool looking town site. So it's up on top of a plateau and so on. But we'll get into that later. Let's see. We want to go here. So here is a view of that spot that I was just looking at. We're sitting on top of a plateau. It's here on the map. We're sitting in this little. That's our little arrow. This is the in-game map. That's the plateau we're sitting on. And this is the view that's rendered. I currently have the sea routes plotted as wood roads, just so I can see where the sea routes are going and make sure they're going okay. This is sort of a little tower I put near the sites of the towns so that they're easy to see above the trees. But I wanted to talk a little bit about how world generation works from the ground up. We had some questions on the Discord, and I got into a really long discussion. I thought I'd put together some diagrams and kind of go over, my theories on world generation for Mythruna and where we are now, what parts are open source, and so on and so forth. So, to make this particular view, Minecraft will call them chunks. I call them columns. If we go back to this old thing, a column are these little 32 by 32 by 32 leaves. And so each of these has 32 by 32 by 32 1 meter blocks. And so this is a stack, called a column. Currently in Mythruna, this is 672 meters high by 32 by 30. So this is kind of like what Minecraft would call a chunk, only I guess a Minecraft chunk is like 16 by 16 by 256 or something. We have more data in our quote-unquote chunk. And then the engine deals with these things called tiles, which are sort of 32 by 32 of the columns, and we'll talk a lot about tiles and where they come into play. So to generate this screen here, which each of these little blocks, they're part of one of those columns, and at some point the columns cut off and we go into the far terrain, and that's where the tiles come into play. So I put together kind of a diagram to show where we're coming from. And if anybody has any questions as I go, please ask. Recognize there's like a 10-15 second delay, so I might get a little ahead of your question. It doesn't mean I'm not going to answer it. Just anyway. So yeah, so here I'm talking about this screen. We have columns based on this screen. We have some number of columns. I think the default clip is 3, so not very far even. There's just 3 columns out. It still presents a pretty good view because of the far terrain, et cetera, et cetera. So each of these columns is actually run through sort of a process to generate a tile. And tiles have a low res, a medium res, and a high res version. So the low res version is used for things like the map and the far terrain, the super far terrain. Medium res is used for medium resolution terrain. And these are just essentially 2D flat images. They include, like, the terrain image includes elevation and land type, which is a combination of like what kind of ground it is, how wet it is, and so on and so forth. But there's lots of these layers. There's the terrain image layer, which controls the terrain and what type of block or what type of terrain it is, sand, dirt, whatever. There's a fluid image, which controls what type of fluid is there and where its elevation is. There are influencers, which are kind of what the building. Oh no, rivers and caves would be influencers. They influence the terrain, and that they may add or subtract terrain or move the elevation around. Like the rivers will lower the elevation in the elevations, and then the morphs or the buildings. They're actually kind of like block inserts, but they can do all kinds of things. They basically mostly don't operate on the tiles, but only on the columns. And then of course the trees. And the trees are called out special here because through the world interface there's a special query to query the far trees so that we can render all these imposters to make the cool far forests and stuff. So each tile, low res, medium res, high res, will run through a list of tile functions. Some of them load data from the database or pull it from the fractal. Others are pure generators where they'll take that fractal data and they'll turn it into a terrain image or a fluid image, or they'll pull from a database of buildings and insert the actual building morph structures that will do the building inserts, or they'll generate trees and so on. So for each tile, when you grab it the first time, it's going to run through these list of tile functions, which will check if it's already in the database. If it is, it'll load it, or it'll generate it from the fractal, etc., etc. It runs through all these generates all these layers, and the layers then can operate on both, like influence and morph layers and so on can operate on the terrain image layer to adjust elevations and things that they operate on the terrain layer. So each of these layers can operate on anything else in the tile, but then also during column rendering, each of those layers has a chance to edit the column and push blocks around and do that kind of stuff. So this is the low level stuff. That's all part of Moss, the open source piece, and there's some my old desert demos that I used to show that had the 1,000 building cities and things that I used to show videos for. That's all part of the open source stuff. That's a sample application. A couple developers have used it and started creating their own games with it and stuff. It's available early access to patrons only because I'm not in a position to support the API right now. And before I release it, basically I want to get Mythruna to a certain point where that API is solidified, and then I'll be ready to release it in a way that I'll be able to support it, because I'm not ready to support it yet because there's still too many things changing as I find missing things in Mythruna. And speaking of missing things in Mythruna, so we come up to the next layer, which is, we have these tiles. They represent sort of 1024 by 1024 meters. So if you want to think of that as a kilometer, and so each of these squares in the map is a tile. And there's that square where we were looking at before. So then the next level up is something I call a sedectile. I made up a term for it because you run out of names for tiles. Sedectile is my term for 16 by 16 area of tiles. So there's 16 across, 16 wide. These are sort of the unit of large scale generation, because if you were standing in the middle of this, the farthest you can see using the far terrain is right about at the edge of this. So it's a useful unit for generation, because if I'm standing in the middle of this, I only need this tile, but if I move a little bit, I just need the next tile. And so you think if I had 3 by 3 tiles, I could move anywhere inside this tile and I would never see beyond the edge of the generated world. So it's useful from there. And so a sedectile is, say, they're the unit of large scale generation where we're going to place the towns and roads and things. And so that's what I call currently a workspace, because I'm running out of terms. So we can see like that sedectile here is in the middle, and we've got a 5 by 5 grid. This is my current strategy. I think it's working so far. The idea being that for things like rivers and roads and that sort of thing, they need to be able to generate across tiles, or across sedectiles. So a river, might starting here might generate out here. It's in fact quite common, but generally not beyond 2 tiles. I think that's going to be the limit. And so for generation, if I'm standing in this tile, I can see towards the borders. If I start to move the edge, I can see into this tile. By the time I've crossed this border, now I'm getting to the point where if I'm halfway through here, I can see into this next tile. So we need at least 3x3 fully generated sedectiles. So, or at least, and by fully generated, I mean not fully generated down to the block level. I just mean we need to know where all the roads and rivers and things like that are, so that when we start generating the low resolution tiles, we know where to put the rivers and we know where to put the roads, so that they can carve out of the terrain, tunnels and caves and canyons and things. So from a workspace perspective, we need to generate, at least 3x3, and we'll partially generate out this extra border, and that's because we may have rivers that start in here that generate into here, similar cities that need to generate roads into our cities. So in order to fully generate this 3x3 section, we actually needed to have started generating 5x5. We obviously can't fully generate these because they don't have the next border, and so they'll be in kind of a weird limbo state where maybe we generated the near half of them or something. That is yet to be worked out. That's I gotta solve that problem soon. But so at the workspace level, that's large scale placement. This is how we propagate the rough rivers, rough rivers, exact caves, craters, caves that they don't depend on the terrain, so it's really easy to plot them. The cities and towns, because they depend on their placement, depends on sort of the strength of their probability based on other things, land specific points of interest, whatever my imagination comes up with there. I just pull up things, monoliths, churches, not things that can't be considered towns but would still be generated on the map in a way that you could see them from far away. And then of course the roads and paths that connect all that stuff. And I have some internal rules that I use, a whole list of things that I keep to myself, but about how frequently things should be around, because I want to avoid the sort of No Man's Sky effect when it first came out, where a lot of neat terrain and then nothing in it. So there's sort of rules that I have for myself that wherever you're standing, you should never have to walk more than X meters before you find this kind of interesting thing or that kind of interesting thing. Even in the middle of wilderness, maybe you find a spawn generator for some kind of monster, or a dungeon entrance, or a hollow tree, just any little random thing to break up the sort of monotony that can happen for generated terrain. But we're not there yet. We're still sort of generating the towns. Let me know if you have any questions, if you happen to be online watching this right now. But that's sort of where we are. And so when we look at the mapper tool and I zoom out, these grid lines here are those sedectiles. So if we're standing here, I need to hard generate this 3 and soft generate the outer border. Right now I'm kind of hard generating all 6x6 here, which is a lot more data than I need to, and I do that for 2 reasons. One, it gives me a wide area to play with, and I get like a continent where I can get rivers and stuff, paths and things all the way across. The other thing is the time requirements goes up kind of geometrically, right? 3x3, that's only 9 sedectiles I would have to generate. 5x5, that's 25 sedectiles I'd have to generate, which is not that much more, but it is more. And then of course 6x6 is 36 sedectiles, so that's essentially 9 more tiles than I would have had to generate in the 5x5 grid, and I'm fully generating them. So it's super painful when things are slow, is what I'm saying. And I know that if it takes 30 seconds to generate a 6x6, then it's going to be entirely reasonable to partially generate this outer border and fully generate this 3x3, because I've been dealing with the pain of the 6x6 I'm optimizing. Of course, all this stuff still running in Groovy anyway, and it'll be faster in Java. So that's sort of where we are with that. Um, let's talk about the town placement. One of the questions was about that the towns seemed really uniformly placed, and there's kind of again, these are supposed to be the cities. The idea being that if you're so there's a million different ways to generate a world, right? But I wanted to be able to still have wilderness where they're, completely unsettled areas. Like here, if you're in here, by the way, this round thing, that's as far as the user could possibly see in the game. That's where the horizon clips. And so, here, if you're standing in this, as far as you can see, there is no civilization. So I want to have places like that. This desert I wish was larger, but it's still pretty big if you're wandering around. Again, these big hexagons are representing about 1 day travel. The idea being that if I'm standing here and I start walking this way at sunset or sunrise, then by sunset I'll have gotten to the middle of this one. That's about the distance if you run. And so if you're walking and fighting things and exploring, it could take you quite a bit longer to reach here. But if you were running at a flat out 6 meters per second, you'll get here between sunrise or sunset and sunrise. Sunrise and sunset. That's what. Yeah. You see, some of these are farther apart than others. Some of you can see, like here, if I'm standing on this town, these are still within my border. I won't be able to see them because the clip for buildings stops right about here. But like over here, from this town, if there's something really tall here, I'd probably be able to see it off in the distance, a little thing up here. Here's the fake spawn that I'm using. We may look at that in game. So there's a fake spawn. Within here I can actually see these towers. Well, I mean I can't because they were slightly behind cliffs or behind trees, but I have a screenshot of me standing at this town site looking back up at this mountain, and you can see the spawn tower as a little teeny thing. I don't know that I have that one open at the moment, but we'll look at it in game in a little while. So anyway, we had the rivers generated before. From that and other things, we generated probabilities. And so again, so I was starting to say before, there's a million different ways to generate cities in the world. I chose to take a sort of imagining how the world evolved. So at the first pass, it comes through and it plots settlements along the coastlines. Basically anything within a certain distance of the coast that has ports and things gets a higher probability. And so we generate all the coastal cities. And then from there, maybe I can illustrate this. See. If we go into settlements, can I render? Do I have a... I'm trying to see. I used to have a thing that would render the probabilities. Yeah, so here we are doing the first pass for just the port cities. And there was a way to draw the probabilities at each phase. Oh yeah, I am still drawing the probabilities. So if I only generate, let's see, how do we do this? So here's the first pass that randomly picks them from the coastline, the ports. And so if I make sure that I don't generate anything else, so let's see. Yeah, can I just show the base probabilities? I should have wired this stuff up. So if I say false here, we won't generate any ports. Actually, it doesn't matter if we generate the ports because there's nothing modifying the... That's this stuff. If we... if we don't reset the probability there, and we don't reset any of those, and we don't do the second pass, then it should show... Yeah, okay. So we started with... Okay, maybe I should... Okay, no, I think this is good. So we started with a certain level of probability, and these white lines show, you know, what the probability was at a given location. And why? So we flat out, for the major cities, we flat out don't let them appear. That's not true. We go through all the best ports, and we do adjust their probability. So let's leave this part out and try again. Oh, this is going to generate so many cities. This is why. Yeah. So this was a bad idea. So yeah, so if we didn't do that, if we just based on probability and, you know, the score at each of these sites, this is everywhere we would have generated major cities. And that doesn't seem realistic to me because of, you know, if you were thinking about how the continent evolved, you know, settlers would find, you know, coastal cities, they would found them, and if two were close together, it's just as likely they would have just made one. Like, there's nobody going to start a city here. And this is, so these are the sort of coastal settlements that have been around for 100 years. We're just generating the world from oldest to newest kind of thing. And so whenever we decide we're going to generate, again, and we go from most likely to generate to least likely to generate based on probabilities, you know, and these scores are based on whether they're near rivers, near mining, you know, near forests and things, near food sources. So whenever we generate one, we lower the probability of everything within a certain radius, and that's what this was doing. And so this is going to suppress based on distance. Anything, I think the threshold is 3 days. So within 3 days running travel, right, these big hexagons, we won't generate another coastal city, or we'll suppress its probability. If it was very highly probable that it would generate one, we would generate it anyway. And that actually happens over here. There's, oh no, these must generate secondarily. Yeah, okay. Over here there is a place where two port cities generate really close to each other. So these would be, according to this algorithm, these would be where the major cities would have formed for one reason or another. This is where the game, where the algorithm thinks the major cities would form, and we've still got these probabilities scattered around. We can see we lowered all the probabilities within this range and so on. Now if we reset all the probabilities, which is what I did here and here, so basically within a certain distance of the spawn, I want to within a certain distance of the spawn, I want to reduce the probability, and in a larger distance, I want to raise the probability. So what that means is I'll make it like a donut around the spawn. Actually, let's just do that, and I'll show you. So to generate the first set of towns, and we find that spawn. Yes, so see, it made a donut where so it decreased the probability immediately around the spawn. We don't want things to generate right on top of each other. Of course, if something was super high probability, it still would have happened. Like if there's a gold mine right here, that gold mine might have still happened based on dice rolls. So we increase the probability around here, and we do that for all of the cities, all of the existing towns that we just created, the port cities. And so we end up with something like this. So we get higher probability here, lower probability immediately around, but you can still see some spikes, some little white dots where things still might generate a town, and then it goes up in the distance. The idea behind this is we're generating the larger towns that might be your mining towns, your farming towns, and things that would be feeders, sort of trading partners for these cities. They would feed these cities. And it also keeps the interior from, there's probably nothing's going to generate here because there's no probability. And so that would generate the next set, and that is where we ended up. I think we were almost there last week. And so if I take this out, we get the and each of the new cities does a similar kind of suppression, though it's a little less dramatic. And so now we've generated some inner cities that would feed those major cities. Like this might feed it down the river, stuff like that. Over here we ended up generating two right on top of each other, which I think it'll be an interesting generation challenge, because each of these cities has ports. This ends up having a port right here near this river. This ends up having lots of possible ports out the side here. And so at some point, similar to how I have to merge lakes together, I'm going to have to figure out I'm going to have to merge cities together. But I kind of think it'd be cool to keep track of the fact that they were originally separate as part of their lore, maybe. I don't know. I have dreams. So let's do the roads. The roads take a little bit to generate. Let's see. Roads. Actually, and then we want to say, alright, so this is going to generate the roads and the sea routes. And then I'll break it down and I'll show how they actually do that. At this scale, it takes about a minute because of all the extra data we're generating. Let's see, we've already done the roads. That took 19 seconds. It took roughly a million iterations to do that. And then now we're just doing the sea routes. And that took 26 seconds. And so here we have, all those cities and towns connected, and from this I can do additional things. So here we have some that never got connected by anything. This turns out not to have any ports. It just generated for whatever reason. This definitely doesn't have any ports. It just generated on this small landmass. So this is a city, this little town on its own, and that might exist fine. Basically, there's no coastal access for large ships, and there's too much water for bridges and things. So, it'll exist there. It'll do its thing. Maybe it's available by airship. The thing is, I know, in the graph data structure network, if you whatever you want to call it, there's nodes and links. Now these towns are all linked together. I know that this town has routes to connect it to this town and this town and this town. I know how those routes are connected. And so I can decide, which towns are a trade hub, which towns aren't. Like this guy, this is the one I was showing you earlier, which is, a town on a plateau. And that'll be an interesting experience. But they basically got all these sea routes that, exit here. No necessarily natural resources, though this is entirely a forested plateau. So, there's certain things you can think about that are not hard for a computer to determine. I know there's, able to be stone quarries around here. I know that there's trees for farming trees, so the city could be made out of stone, wood, whatever. But it happens to be a convenient stopover on the way to a bunch of other things. So this would probably be, a major trade hub between all these different cities, and that'd be its primary form of trade. And in fact, that you'd have like quarryable cliffs here to build, find all kinds of different kinds of stone, whether chalk or marble, different things. Anyway, you can imagine the computer doesn't have to think very hard about this stuff. It's just a kind of a bunch of if statements, if you want to think of it that way. So we have these roads, and I want to talk a little bit about, again, just like the rivers, these are rough roads. They're not the actual roads that would be in the game. They're just sort of the rough plots. Each of these sections is 128 meters, and we're not going to have 128 meters of straight road here. What happens is that within a 1024 by 1024 tile, however that big, okay, I guess it's 1024 by 1024 tile would be about this big, one of these hexagons. Within that, we sort of take where they cross the border. Hey, Jeremy, how's it going? So within that, we sort of take as it crosses the border, and then we replot. We know it crossed the border here and across the border here, and then so we can replot a more detailed path based on the actual terrain. But out here, it would be incredibly expensive to meter by meter have plotted all these roads. So we get the general idea of where the roads are, and then when it comes time to actually generate the data within this particular 1024 by 1024 tile, that's when we actually generate where the real roads go. We just know that a road goes through there and it's roughly here, and because we know it's roughly there, we can influence the sort of A-star algorithm that would plot the road around obstacles and decide to make a bridge and make tunnels, whatever, by trying to adhere to this. It would prefer to follow this path, but it doesn't have to. So that'll be something I have to start messing with soon. But that's where we are with this. Let me talk to you about how... Wow, we've taken up a lot of time. I hope this is interesting. I had questions, so I thought I should explain it. But I hope this is interesting. So let's talk about how the road's generated. We will go here, and we will say, let's not generate any C routes for now, and we'll draw the road iterations, and we'll limit this to, we'll start with just 100. It's not going to do anything interesting with that, but I'll show you what's happening. So somewhere around here, yeah, okay, here. So it starts out, yeah, it's not, let me do a couple more iterations. Let's do 1,000. So that should have presented somebody, yeah. So what it does is, starting at a particular site, for every site, in fact, it generates a path, right, coming out. It generated a path in all directions, but based on cost, the fact that we had to go uphill or whatever here, these cost a little bit more. So we started doing with this one first because it's going downhill. And so as we increase the number of iterations that we're willing to go, these branch out. And so each of these is sort of the cheapest way to get there. And so here we had one generated in one direction and one generated in the other direction. In fact, if we back this off to maybe 5,000, can we see it happen? No, let's maybe 1,000 should have started it happening. Okay. So what this is telling me is that this change is because these are Groovy scripts, and I have a app state that's watching the files. When you add a new file through one of these add script calls, it starts watching it, and so whenever the timestamp changes on the file, it reruns it. And since it's Groovy, that's why I have these things like markers clear here, because if I didn't, it would just keep adding new roads each time the script ran. So we set the layer. These markers are these lines that I can draw on the map. So when I do markers add line, that's what it's doing, but I need to clear it every time, otherwise it just keeps adding new ones each time the script is run, every time I change it. But that's why. So here, apparently it was cheaper to run all the way around here than it was ever to go out here. There's probably a... let's try 2,000. Was that enough? Yeah, see, 2,000 already hit. So apparently we were able to straight hit this. Why is it not branching out from any of the others? I wonder if I've introduced a bug somewhere with all my commenting out and things. Okay, so we start to get the others. Why are these cheaper? It processes all, so it processes all of the sites at the same time. And for some reason, these all cost less. I know why. No, I don't actually. Downhill is considered expensive as uphill. So going through different types of terrain, different types of trees costs different amounts. But eventually it starts to propagate out from all of the town sites based on who's most expensive, or who's least expensive rather. So the cheapest guys get to propagate first, and apparently these ones that we see blooming are so much cheaper than everybody else that these guys never got a chance to operate. I bet this is because these guys are in deep forest, and that's a big negative. So if we change it up to 100,000, we should already see some interesting... Yeah, so we're starting to see it branch out. Here's a case where two towns finally met. What we have here is it branched out from here, and you can kind of see the line where the two towns met. So this guy branched out, and that's how it works. Each town branches out through the cheapest routes, and you can see here we're really trying. This guy's really trying to make his way over to here. This guy's started to branch out. Let's increment it just a little bit. Maybe we get a little further. So yeah, so I don't know if they actually iterated out. But as we increase the distance that it can go, and there's a hard cutoff, we want to make sure that everything connects within a certain number of days of travel, because we want to have room to... Anyway, the idea being that no one is ever going to travel in the middle of the night, several days in a row just to travel between towns. That's not a road at that point. That's just a cross-country trek. So we limit... is that 1 million? So that should just about make everybody connect. So we limit it to, if it goes beyond like 2 days travel or a day and a half travel, I can't remember what I can scroll down and look at the threshold in a second. What is the, where is the limiter? Yeah, exactly. It's very similar to Lightning. Yeah, I mean, anytime you're doing this sort of path finding, there is a limit. So max path cost, that's what we're looking at. Max path cost. So 46, 1.5 days. So if, and that means that the cities could be 3 days apart, and this is days in cost terms. Like the base cost is traveling across flat terrain through no woods, and if it's heavy woods and going uphill, that might cost double. And so it's like traveling 1 day by crow is the same as traveling 2 days on land or something. And so we see the towns that bridged in from each way. This guy, he propagated out up to a day and a half travel. This guy propagated out up to a day and a half travel, but they met each other in the middle, and this was the best path between them, so that's the road that was formed. It turns out that the roads, if I increase this to 100 million. I think that's 100 million, right? 1, 2, 3, 1, 2, 3. Oh, 10 million. Yeah. It only takes about 1,000,000 iterations to have everybody either give up because it's more than a day and a half's cost, or join together with something else. And so that takes about 16 seconds or 17 seconds or whatever I showed before. And we'll see how many iterations. It's like watching paint dry, isn't it? Okay, so it took 21 seconds. That's odd. And did it in just over 1,000,000 iterations. And so we can kind of see it looks like a cool picture, right? We've got each of these guys propagated out and met in the middle. The interesting thing about the way this algorithm runs is that all of the logic is in this loop that pulls one off the queue and branches it out, and pulls another one off the queue, branches it out, and pulls another one off the queue and branches it out. And so the interesting thing, we're doing this kind of massively parallel based on cost, but that means that I also could have interleaved this with doing the ocean routes at the same time and doing other things that are iterative in nature. So instead of making it multi-threaded, I could have one thread that just calls each of them in a sequence and sort of builds it up as I go. Threads have their own cost, so I have that kind of flexibility. Or I could run 10 iterations, check something else, run 10 iterations, and do that in the background. So these were all the roads that were plotted. We can do the same thing for the C routes. I'll set this down to 0, and we'll start branching out the C routes, and we'll see a similar pattern. And so somewhere, somebody, why it's not doing it? We did 10,000 iterations, and we didn't plot anything. Why didn't we plot anything? Oh, I'm not drawing them. Okay. Yeah, slime mold finding the best path. Yeah, again, there's so many biological and physical analogs to this idea, and it is just another kind of cellular automata approach to. That's interesting. It's still not drawing them. It was drawing them before. Oh, here we go. They're just gray and I didn't see them. Or I didn't save or something. So here we see a similar thing doing out for ports. In this case, rather than plotting directly from the town, you can see they don't actually connect to the town. They plot to where ports would have generated. That's the deep sea, deep meaning deeper than 4 meters deep, the draft of a sailing ship. And so we can see they're starting to branch off. This would be the port for this particular town, and this would be the best port for this particular town. And so, and here's that cool plateau city. And it's cool because, I'm not sure exactly how I'll generate it, but sitting up on top of this plateau is actually a good 20 meters or more down to the coast, which is basically non-existent. So it'll be interesting to carve harbors and things into the side of this. I have to think about that for generation. It's going to be fun. That gets my artistic side flowing. So anyway, these branch out just like before. If we add each new iteration, of course, it takes a little longer. It's geometric. And eventually we see it. Come on. You can do it. Yeah, we see some have already started to connect here, right? So these are the C routes, and if we bump it all the way back up to, the 100 million that it used to be, I think it was 10 million. Yeah, I think we So yeah, that's the hard part about the live stream is any of these things that take a while. Yep, 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 yep. Come on, you can do it. Especially when I've run out of things to say regarding this topic. But I think what we'll do next is, once I've shown this example, so we've got, so it did it in 1.5 million iterations, which means 10 million was plenty. It took 30 seconds to do it. Again, that's because the oceans had to plot a lot more stuff, and if we were only doing, this much, maybe even only the 3x3 in this case, it would take a lot less time. And again, in Java, it'll be faster. So now we've got that, and I think we can start dealing with the next level of town generation. And let me get rid of the water. So we want no water. We want to show none of this. And let's put all of the roads back. In reality, to do this next step, I need to know the C routes too, but not for the same reason. You just go to here. So we'll take it 13 seconds or 19 seconds last time, I think. So what we're looking at, yeah, okay, so we've got our roads back. And so what the next step would be is to calculate probabilities again, suppressing the possibility that our village would form right next to a town. So we'd use a much smaller scope to suppress those probabilities, but then increase the probability of anything within a certain distance of a road. It's more likely to generate. So basically, as the road gets farther away, we lower that boost, but that means that these guys that are we're still seeing their probability, they'll get a super high probability that they might connect to this road, and we might generate a town here because they're on a river. Different reasons that those were left behind even after the last pass. And so these would be the villages and inns and churches and stuff like that. Things that would naturally have developed near the road because they happen to be near the road. And they would have maybe smaller roads and paths and things depending on what they were. But so I needed to know the roads to do that. I don't need to know the C routes to do that, but I do need to know the C routes to calculate sort of how busy a particular town will be, and that'll eventually factor into, it's not enough to be close to a road. If this is a heavily traveled road, that means different things. Maybe its influence distance will extend further because, if 500 people a day travel along this road, chances are there'd be villages and towns all along here, versus out here where nobody ever travels this road. Maybe there'll be just a few stops, a farm or something. But that's the next step. So let's see, because I still have 12 minutes left, and we won't have to regenerate these roads again. They're already generated. We should be able to add a new settlements 3. Let's do that. Settlements. Yeah, so the other part of it is that I'm doing all this in Groovy and prototyping it, and eventually I have to convert this Java code and start converting, and do it in a way that I can start replacing this Groovy code with the Java code. I'm almost there. So we've got a site index already. We don't need that. In fact, let's just assume I don't need any of this. And we will, let's see. Let's start by resetting the probability. So same as adjust, except that resets the effective probability to the baseline if it is 0. Where did I use reset probability? Oh, I see. Well, initially what we want to do is go through each settlement and this settlement list is definitely a thing, and reset its probability to its score, I think is what we do. Anyway, so let's add that. So we're talking about rerunning. So I added this new script. In order to make that come into play, I have to come over here and add it to my we want to, after the roads, those 3 not groovy. If I do that, it should run it. Yep. And now it's now in the list of things that will be checked for. So reset the probabilities. Then there's a thing down here I can steal that would draw the probabilities. And so this should have, yeah. So now we got all our probabilities back. These are the raw probabilities that a town would form, just based on resources and various other things. I should probably make a function to break out why a certain site has it's an adding of all of its different characteristics as far as mineability, forestability, farmability, etc., which you guys should have seen last week when I showed that image. Okay, so now the next step would be to reset sort of for each of these towns. We want to see, what is the difference between reset and adjust again? Same as adjust, except that it resets the affected probability to baseline if it is 0. What? Sometimes I leave comments to myself that make no sense. So adjust probability will raise it up or down based on distance. And reset probability, so if the site probability is greater than 0 and it doesn't already have a town, we add it to the sites that we changed. We add to the sites. Yeah, because we use this while we're iterating. But otherwise, we're setting the probability to, we're adding or removing it. Okay, so here, if the factor is greater than 0, we set the score based on the factor. Oh, times the site's original score. Okay. Oh, so if the existing probability was 0, we set the sites. Okay, I get it. That's the difference. And then based on the factor, we adjust it again. So we're resetting and adjusting. Yeah, great name, Paul. But I'm going to steal these functions for my other. Steal these functions for the other script because I don't feel like making them part of the global bindings because I'm lazy and we're trying to get something that we can look at. Okay, so over here, we shall iterate through each of the towns. Okay, so here, this is the other thing we want to do. So we go in here, and we're going to see something in a second, I promise. So true. I just like to make these blocks so they're easy to turn on and off. Also gives me an extra indent, which I'm used to having. Okay, so yeah, we're going to adjust these are not the cities, so we don't need to go as far. The boost's probably okay. The radius, though, we want to maybe. We really would like to make this based on the city size. So a big city probably wouldn't have lots of tiny little villages right on its gate, right? But a smaller city might be spread out in a different sense, right? Maybe this guy is not visited so often, and so he's a relatively small city, which means there could be villages dotted along here, because instead of being one massive super city, it's just a smaller city with nearby supporting towns within a quarter of a day's travel. That farmer can bring his goods in, and so on and so forth. Whereas a big city that's well traveled and huge, it seems likely that over time they would have subsumed or consumed all of those cities and made them part of themselves, and so you wouldn't have any nearby. Anything else would be farther away, or they would have been gobbled up by the city as it expanded. So in reality, these adjustments to City Boost we're doing would be based on the town size, which we have not calculated. That is something I need to calculate based on trade routes and things, which I don't have yet. So we'll just do the lame way, and we'll say within a day's travel, let's call it Town Boost, because so it's in days travel. We'll suppress or we'll boost anything greater than that within a day and a half's travel, in this case 1.5, and we'll lower it by a lot, and I may change that in a second. So this will change everything. Oh, research property day for class. Oh, okay. Must be a quote-unquote constant in my other. Yeah. So we'll just keep the bad pattern right here. Okay, so this should make our donuts again. Did it run it already? Yeah, okay, so it did make the donuts. I think it's probably too dramatic. We went maybe to so anyway, this is roughly a day's travel here. We've lowered these things. The other thing I need to do, and I don't think I'm gonna have time to do it in this live stream because we got like 3 minutes before I normally stop. But to boost the near the roads, maybe what is the easiest way to do that? I think. Let's see, how do we draw the roads? We draw them. All routes route. This is not the way to really do it, but this will illustrate what I'm talking about. Normally what I would do is I would calculate for each of these, I would calculate its distance to whatever nearest roads and use that as a sort of indicator. So as things get farther away, they get a lower score. But in this case, I'm just going to, for every spot that has a road in it, I'm just going to plot around it and increase the probability around it. Actually, we can use these. I just feel like this is going to be slow and not as accurate. So actually, we don't need that. We just need this. So we're iterating over all of the routes, each cell that's in that route on its path, and then we'll reset the probability for the location. I'm leaving V for something else just in case. And so we want this to be a really short radius, though. In fact, reset probability is going to go through. Oh no, it's being smart. Okay. So let's make this radius 256. And we'll boost it by 0.5 so we can really see it. Let's see if that does. I think this is going to take a long time. Nope. Okay, so we boosted the probabilities along the routes immediately along. See? In fact, this is basing it on distance. It's interesting. So if we made it a wider distance, like within half a tile, oops. Actually, let's do 513 because then it'll catch one more. I don't remember whether I did less than or equals to or not. So yeah, so all along these paths. And the thing is, because I'm doing it based on each point, then a lot of these get extra probability added to them because, you know, this one will do everything within its radius, this one will do everything. So there's a lot of overlap. And what we really do is, you know, set values only once instead of keeping adding to them. That's why this guy got so many, because he has, you can't see it, but there's a lot of overlapping routes here because I have not resolved them down and put crossroads in. So the fact that there's a route here and there's another route here and there's another route here means these probabilities, you know, got not just doubled but you know, tripled. But like I said, these individual points, because of the way I've done it, they'll affect everything within their radius, and this point will affect everything within its radius, which overlaps, and so then you get these higher scores. Some of that I actually want. I want things to be more likely to generate near the crossroads, so I actually may leave it in, and it could be that, you know, the problem is this is automatically doing exactly the opposite of what I want to do. If this was a really busy city with a lot of trade here, I probably wouldn't want to generate stuff. I don't know, maybe I'll leave it. It could make some interesting stuff, but if we pan out, we can see probabilities increased a lot right around all of the roads. And so that would be the next thing I would do is go through a pass where I go with the best probability, you know, again, influence down anything nearby and generate these next level towns based on probability. I think that's where I'm going to end it. I'm sorry I didn't get a little further, but I'm actually getting tired of talking because I've been going nonstop. But does anybody have any final questions before I close it out for the night? This puts me in a good position to do the next thing this weekend, though, so that's good. Any questions? I think I promised to show some stuff in game, so let me kill that. Hopefully there was no questions that would require me to run that. But let's look at the crappy roads in game. It's kind of fun. Real quick. And then you guys can think of questions if you have any, if anybody's still online. I have not checked the stats. Yeah, 3 concurrent viewers. 4, maybe. Alright, so let's go back in here. No questions. Okay, so... Okay, it's nighttime, and I know historically speaking that YouTube does not like the dark. So here we are on that plateau city, or plateau town, excuse me. And the so we've got like ports over here, and I draw little docks where the port was able to get as close to the shore as it could. Just for markers, and we can see that you know, I'm just rendering garbage wooden sort of roads above the city. If we look over here, this is us pointing in this direction. They go off in different directions based on that earlier view. I actually don't think I have that. Yeah. Okay. So those are useless. But anyway, if we go to the fake spawn, warp. I think it's fake spawn. Yep. All right. So you can see everything loading in. See the? I think this is cool. You can see the roads, sort of going off in the distance, the crappy roads. And here we are on top of the spawn tower. And another road off in the distance here. Thing is, like cross valleys and you know, carve right through the mountains and stuff, and that's not realistic. Yeah, there's the little tower that's generated for this site, and so you can kind of almost see a little. I think that's the, like right there. I can see a little tower or something, but I'm not sure. One way we can find out for sure is, did I pause the, let's make time stop. So let's see, that little guy right there, where my bubble is. Keep an eye on him. I'm moving it over here so that when I go into this menu, so this was it over here. If I turn off the trees, sometimes we can see a little better. Oh no, that was just trees, I guess. And then sometimes I cannot turn off the can I? I can physically, but I never added the toggle for it here. Turn off the sky. But anyway, it's not just the fog. The buildings stop appearing way sooner than the fog. So what I can do is see if we toggle this, we can see that the roads turn on and off because they're far structures. If I turn around one of these directions, you can actually see the tower off in the distance. That's it right there. Right, that little guy in my bubble. So keep an eye on him. So if we turn off the far structures, you can see him come and go right there. This guy right here. Look at that spot as I do this. So that's where the other tower is. Yeah, so it like carves into the ground, so we see a little bit of the carving of the ground, but the actual you know, cobblestone road gets drawn in. If we put the trees back, we can't see that tower. But if we spawn over, I walked down this road down here, and I can walk down it for a second. Yeah, so these are the little stone canopies that spawn at the town sites, which I think looks kind of cool. And you see it's just carving straight through. It's not. This is what I'm talking about. Really the roads would you know, generate more detailed pathfinding down at this level, and these are just kind of the rough pathfinding. So if we walked all the way over there, it would take us about 20 minutes. So I'm not going to do that because I have a marker set up already. I think it's, oops, mark, what's it called? Mark near fake spawn, yeah. So warp near fake spawn. Yep. So here we are. Whoops. Let's stand back up on the wall. Stand on top of the fire. And so if we look, which direction is the spawn? I think it's up there. Yeah. It's up there, but now we can't see it because it's too daylight, I think. Oops, wrong button. But earlier I took a picture of it. So if we turn the far trees off, far structures, yeah, you can't really see it. If I change the time of day, maybe. So that might be a tree. Let's see. Far trees. Okay, so I was wrong. I took a picture of it earlier, and that was actually the tree. So we can't really see it from here, I guess. But that doesn't look like a tree. See, doesn't that look like a spawn tower to you? Yeah, so we got this whole road here. The other thing is the trees, they don't know better. When the roads are placed, they don't make the ground unplantable, so the trees just grow right up through the road, which is kind of cool. We're going super fast. So yeah, so see, we can see that it's a tower right there. Oh no, that's the tower over there. Okay, so well, I took a fake picture earlier. That is a tree indeed, so let's see. Can I stand on top of a... Nope. I cannot work my controls today. Okay, so that I believe is the spawn tower. And we can confirm. So it was behind the cliff. Behind the... Yeah, that's the spawn tower. So that was behind the mountain before, so we couldn't see it. Anyway, so that's the kind of in-game stuff going on. And I look forward to having real roads with, this road would have obviously routed around that little hill instead of carving right through it. But it's useful for deciding how long things take and seeing cool views like this. So yeah, we couldn't see it because of this mountain right here. As we come over here, we can see our other tower over there. So anyway, that's it. That's all I'm going to cover today. Thanks for joining me. Thanks for staying the extra 12-15 minutes for the eye candy. And I will see you guys online. Or if you're on the Discord server, say hi. Otherwise, I will see you guys on next week's live stream. Thanks for joining. Let me do my normal closeout, where I once again thank the patrons and do the thanks for watching. Now, like, comment, subscribe, share with your friends. If you know somebody else who's interested in world generation, point them to some of these and maybe they'll be interested in the topic or have their own thoughts. Otherwise, I will see you guys.